fifth graders, and welcome to your next math virtual learning lesson. Make sure that you're ready to learn for today. Have a quiet place to work. Have out your pencil and math notebook, and message your teacher if you have any questions. For your warm-up today, we're going to review how to multiply fractions. Make sure your answer's in simplest form. Pause the video and hit play when you're ready to go over the work. All right, let's take a look at your answers. For number 1, we're taking 2/5 times 1/3. If you can recall back to that lesson, in order to multiply fractions, you multiply your numerators together and then multiply your denominators together. So for our first problem, we're going to take our numerators 2 and 1 and multiply them. 2 times 1 is 2. And then we multiply our denominators. 5 times 3 is 15. Then you have to ask yourself if that can be simplified. Is there a times table, other than 1, that gives you 2 and 15? Nope. So that's in simplest form. Did you get it right? Good job. Let's take a look at number 2. 6/7 times 3/4. Multiply your numerators. 6 times 3, 18. And then multiply your denominators. 7 times 4, 28. Ask yourself, can I simplify this? Are there any times tables that would give me 18 and 28? Yeah, the 2 times table. So I can divide both of these guys by 2. They're even, so I know I can divide them by 2. 18 divided by 2 is 9. And 28 divided by 2 is 14. Are there any times tables that give you a 9 and a 14? No, so that's in simplest form now. How'd you do? You're going to need this skill to be able to do today's work, which is, coming up, today we are going to be able to divide fractions. When we divide fractions, we're really not dividing fractions. And I know that sounds funny because, when we multiply fractions, we multiply the numerators and we multiply the denominators. But when we divide fractions, we don't actually take the numerators and divide them and then divide the denominators. It doesn't work that way. We're actually going to turn all division problems into multiplication problems. So when we divide with fractions, we're actually multiplying by the reciprocal of the second fraction. And I'm going to tell you what that means in a minute. But there are a couple of steps that you'll see throughout this presentation at the top. Okay? And this is what we do. Step 1 is to keep the first fraction the same. And then we change the operation to multiplication. And then we flip the second fraction upside down, which will turn this problem into multiplication. So then you multiply the fractions. But let's take a look at this R word, reciprocal. Have you ever heard of that word before? If not, let's take a look. And if you have, let's see if you remember. So reciprocals. Say that with me. Reciprocals. Well, what's the reciprocal of a fraction 6/7? Well, the reciprocal is when you flip the numerator and denominator. So I'm going to take my numerator and my denominator and switch their positions. So the reciprocal of 6/7 is 7/6. Okay, we took that fraction and we flipped it upside down. A way to remember this is reciprocal means refliprical. I think it's funny. Reciprocal, refliprical. So the reciprocal of 6/7 is 7/6. I want you to give that a try. So go ahead and write the reciprocal of those two fractions. Pause your video and hit play when you're ready. All right, let's go over your work. What's the reciprocal of 3/8? To do this, remember we switch the numerator and denominator. So the reciprocal of 3/8 is 8/3. Notice I did not put an equal sign because they're not equal to each other. 3/8 and 8/3 are not the same thing. They are reciprocals. So that's why I have an arrow there. Number 2, what's the reciprocal of 7/10? Well, if I switch their positions, I get 10/7. So the reciprocal of 7/10 is 10/7. How did you do? All right, we need to know how to use reciprocals to divide fractions because of the last step, which is flip. So let's take a look at how to divide fractions. Here's our first example. 2/3 divided by 1/6. Now remember, you can't just divide the numerators, divide the denominators. That doesn't work. All division problems with fractions must get changed to multiplication problems. If we apply our 3 steps, keep, change, flip, this is what happens. So we need to keep the first fraction the same. That means the first fraction, 2/3, stays as 2/3. We don't do anything special to it. It's still first and it's exactly the same. Then I need to change my operation to what? Who remembers? Multiplication. Making this into a multiplication problem. Then I have to flip the second fraction to its reciprocal. So what's the reciprocal of 1/6? Yeah, 6/1. I just switched the numerator and denominator. So take a look. I kept my first fraction the same. I changed from a division problem to a multiplication problem, and then I flipped my second fraction upside down. And now you have a multiplication problem. That's why we reviewed that in your warm-up today. All right, so let's figure out what this equals. Multiplying my numerators. 2 times 6 equals 12. And 3 times 1 equals 3. Let me make sure this is simplified. 12 divided by 3, or 12/3, is actually equal to 4. So 2/3 divided by 1/6 equals 4. Now, you probably are like, well, wait a minute. I thought 2/3 times 6/1 equaled 4. Yeah, they both equal 4. Okay? This problem is equivalent to this problem. Even though it's a different operation and the second fraction looks different, they're actually the same thing, and they give you the same quotient, the same answer. Let's try another one. 5/9 divided by 2/3. Remember, keep, change, flip. You have to do that, okay? That's how we do this division of fractions. We do keep, change, flip. So we keep the first fraction the same. So I will rewrite it using the same first fraction, 5/9. And then we change the operation to multiplication. And then we flip the second fraction to its reciprocal. reciprocal, reciprocal. So 2/3, if we reverse those numbers, our 3 is on top, our 2 is on the bottom. Now we can multiply. 5 times 3 is 15. 9 times 2 is 18. Is there a times table that gives you a 15 and an 18? Yeah, your 3 times tables, which means I can simplify this by dividing by 3. What's 15 divided by 3? 5. And what's 18 divided by 3? 6. So 5/6 is the answer to our original problem. And even after we did keep, change, flip, it's the answer to that multiplication problem. All right, are you ready to try this on your own? Here are 2 problems. Remember, keep, change, flip. Answers are always in simplest form. Pause the video, give these a try, and hit play when you're ready. All right, let's see how you did. A helpful hint is to always write the K for keep, the C for change, and the F for flip. I remember doing this when I was learning this skill when I was your age. I would write a K under the first fraction, a C under the operation, and an F under the second fraction. Now, it's not Kentucky Fried Chicken. Okay, a lot of people think KFC. It's Kentucky Chicken Fried, I guess you can think of it. Okay, keep, change, flip. So let's do this. Let's keep our first fraction the same. 1/2. Did you do that? A common mistake is to flip both fractions because we like flipping so much that we do both. Now, keep the first fraction the same. All right, did you change to multiplication? And then did you flip? Don't forget to flip the second fraction to 7/4. And now we multiply. 1 times 7 is 7. 2 times 4 is 8. And I know I can't simplify that because 7 and 8 are next to each other on a number line. So it's already in simplest form. How'd you do? All right, let's look at number 2. We keep the first fraction. So that's still 3/8. We change the second fraction to multiplication. Oh, I'm sorry. That didn't make sense. We change the operation to multiplication. And then we flip the second fraction to its reciprocal. What's the reciprocal of 2/9? 9/2. Very good. 9/2. And now we can multiply. 3 times 9. Good. 27. 8 times 2. 16. Oh, this is improper, which means we have to do that division to simplify it. How many 16s can I take out of 27? Well, if I take 2, it would be 32, which is too high. So I can only take one. I'm going to do it up here so I have more space. I can only take out one group of 16 from 27. Well, if I take 16 away from 27, how many's left? Yeah, 11. And I keep my denominator. So you should have gotten in simplest form 1 and 11/16. How did you do? Just remember, keep, change, flip. All right, let's do a little review. We're going to practice making equivalent expressions. So I have some, there we go. I have some division expressions with fractions, and then I have some multiplication expressions with fractions. And we're going to find the pair to see which one shows that keep, change, flip. So I know they're a little small. This one says 1/3 divided by 4/5. And we need to find its match. So which of these expressions would be the same thing, the equivalent when we do keep, change, flip? So this one says 1/3 times 5/4, 4/5 times 3/1, or 5/7 times 11/6. Which one shows keep, change, flip? Yeah, 1/3 is the keep. We change to multiplication, and then we flip 4/5 so that it is 5/4. Very good. All right, let's look at 4/5 divided by 1/3. If we do keep, change, flip, which one of these do we get? Yeah, keep the 4/5, change to multiplication, and then the reciprocal is 3/1. So if we have 5/7 divided by 6/11, I covered the answer because there was only one left. So let's see if you can figure out what it would be. What would we do to get the multiplication sentence? Yeah, 5/7 times 11/6. Very good. All right. To finish the lesson, there's a YouTube video that I want to show you. It's a song about this skill. And here we go.
Yeah, you know how this go. Keep, change, flip. Simple, right? Divided fractions. Vocabulary. Let's go. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Dividing fractions is easy. That's no lie. You just flip one, yup, then you multiply. Don't flip both, because that'll be strange. You need to keep one exactly the same. Yeah. Then the sign gets changed, division to multiplication, that's okay. Then flip the second fraction like you're on a grill. We multiply what's left, that's really real. Take 3/5 divided by 2/3. Keep, change, flip, that's the word. Keep 3/5 the same, change the sign so we multiply, that's the game. Flip 2/3, we get 3/2, then we can multiply, and so should you. 3 times 3 is 9, 2 times 5 is 10, 9/10 can't reduce it, that's the end. Why do we flip it? I'll explain the math. Dividing by 2 is the same as multiplying by half. 20 students in your class divided by 2 would be 10 students. Or we can do 20 students in your class times half is 10. You'll see, you get the same thing at the end. Dividing is multiplying by the reciprocal. Keep, change, flip. Yeah, that's the simple rule. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions.
Was it a little creepy that I was just kind of hanging out in the corner during that? It was a little awkward for me. I was going to X myself out, and then I figured, nah, I'll creep you guys out a bit. All right, well, thanks for watching. If you have any questions, let your teacher know. And remember, you have to do keep, change, flip if it's a division problem with fractions. All right, have a good rest of your day, and I'll see you next time. Thanks for watching.